What up, what up? Part two of getting ready for AP Precalculus. We're talking a lot about quadratics, how to factor them, how to solve them, which usually requires factoring, a little bit of quadratic formula, a little bit of graphing, awful, terrible, awful stuff like that. So let's just get started. Find the vertex of y equals x squared plus 16x plus 64. The vertex is the either minimum or maximum of a parabola. This is a quadratic because it's x squared. Since this is a positive x squared, it's going to look like this. The vertex is the very bottom of it. Now, when we have a parabola, a quadratic in standard form, which means x squared plus number x plus 64, the vertex is going to be, the x value is going to be negative b over 2a. Okay, now if you remember quadratic formula, that should look a little familiar. We will do quadratic formula in a little bit though. Now this is just the x value. What's b? What's a? B is the number in front of x. A is the number in front of x squared, and just for funsies, C would be 64, but we don't have to worry about that here. So the x value of the vertex is going to be negative b, which is 16, over 2 times a, which is an invisible 1. So negative 16 over 2, negative 8. Okay, now let me just write that out. X is negative 8. Now, this gets me the x value and the x value only. I'm asking you to find the vertex, which insinuates that I want the point that would be the minimum in this case. So the way you find the y value is you just plug in negative 8 into that guy and do a little bit of math. So let me do that over here. Y equals, I'm replacing every x with negative 8, so negative 8 squared plus 16 times negative 8 plus 64. Negative 8 times negative 8 is 64. Positive times a negative is a negative. This is going to be 128. And this is going to be positive 64. Oh, happy day. Why? Well, when I combine like terms, even though there's no like terms, I mean, like if I add these two together, I get 128. And then if you subtract 128, you get a big fat 0, a goose egg. So y, writing it over here, is going to be 0. Now, if x is negative 8 and y is 0, that means my vertex, which I'll denote as that little v over there, is negative 8, 0. Okay? And that's supposed to be a comma, but, you know, I'm close. I'm just not perfect. Vertex. Fun, fun, funny, fun, fun. Now let's graph. The way that I'm going to graph this is, it's a parabola. I do know that. This is a positive x squared, which means it opens up. I do know that. The last thing I want to do is pick a bunch of x values and assume that what I'm doing is no good. And what I mean is if I know my graph's going to look like this. Okay, but let's just say the vertex is like negative 840, and I didn't know that. So if I create an xy chart, right? And if I'm like, let's try 0, and let's try 1, and let's try 2, and let's try, you're finding all of these points over here, and you will never get to the minimum. So the best thing to do is find out what the vertex is, find out the x value at least, and use that as your center, and everything to the left and everything to the right is just going to be symmetrical. So let's quickly find out the vertex. Again, the vertex is going to be negative b over 2a. In this case, b is negative 2, a is invisible 1. So the vertex is going to be negative 2 over 2 times 1. Okay, doing a little bit of quick math. Negative is a positive. 2 over 2 times 1 is 2 is 1. So the x value is 1. So I'm going to make an xy chart where my middle x value is going to be 1. And then I'll also plug in 0, and then I'll plug in -1, and then I'll plug in 2, and then I'll plug in 3, and so on and so forth. So knowing that 1 is my middle, let's plug it in. The numbers aren't that bad. So I'll show you how to do it once, but everything from here on out is just going to be mental math. All right, so if I'm plugging in 1, y is going to equal 1 squared minus 2 times 1 minus 3. 1 squared is 1. -2 times 1 is -2, so 1 minus 2 is -1. -1 minus 3 is -4, so the 1 value is -4, and that gets me the point 1, -4. Just making sure I'm just doing the math in my head. Plugging in 0 is going to be pretty easy. You would go away, and that's -3. Now, here's the fun part about parabolas. They're symmetrical. So whatever you get over here, you're going to get the same exact thing over here. In other words, if I were to plug in 2, 2 would be, let me see, 4 minus 4 minus 3. Oh, it's -3 again. So at this point, you should be thinking to yourself, well, if I plug in 3, it's going to give me a number, and -1 is going to be the same thing. So if I do plug in 3, right, and let me show a little bit of work, not too much. If I do plug in 3, that'll be 9. If I plug in 3, that'll be -2 times 3, which is -6. And if I have -3, that's 9 minus 6, which is 3. 3 minus 3 is 0. So you're going to be 0, which means you are going to be 0. So let me graph what I have. -1, 0 lives right there. 0, -3 lives right there. 1, -4 lives right there. 2, -3 lives right there. And 3, 0 lives right there. Now, I have all this open space up here, and I'm wondering if I could fit plugging in 4, and I really think I can. I really think if I do that, I will get 5, but let's just double check. Let's add a 4, okay? And so I'm going to show just a teensy bit of work over here. Y equals 4 squared is 16. It's also a fun game. Minus 2 times 4, which is 8, minus 3. And so 16 minus 8 is 8. 8 minus 3 is 5. So 4 is going to be 5. So 4 is 5, which means -2, since everything is symmetrical, is also 5. Now it's a matter of me drawing this graph. And those of you who watched the previous section where I tried to draw lines, you know that this is not going to turn out well for me. So nice and smooth, nice and smooth, nice and smooth. Perfect. Nice and smooth, nice and smooth, nice and smooth, nice and smooth. Perfect. Tried to lean on the thing here and I missed and I slipped. That's why I went like that. All right, let's try another one. Let's see what else we have. We have, factor. Now, factor could mean multiple things. Factor could mean let's find a greatest common factor and bring that out. In this case, I don't have anything in common with these. More often than not in Algebra 2 and in Pre-calculus, factoring means let me give you a quadratic and let's come up with two numbers whose sum is -7 and whose times is -18. Now, if that sounded like it was poor grammar, it is poor grammar. But the way that I remember how to do this is sometimes find two numbers whose sum, add, is -7 and whose times, multiply, product, is -18. Once you do that, you put them in these parentheses right here. There's nothing in front of x, so that's going to be an x here and an x here. Now, this is where it gets a little weird. First thing to do is find out what two numbers multiply out to -18. Do that first. If you try to sit there and come up with all the numbers that add up to -7, you're going to be there all day long. Start with a -18. So I know one's going to be positive and I know one's going to be negative. Now, whichever number is larger is going to be negative. Why? Because a negative plus a positive, if it ends up being negative, the larger number is negative. So two numbers that multiply out to 18 are 6 and 3. Could I take a 6 and a 3 and make them a 7 if I subtract one from the other? No. How about 2 and 9? Can I find a way to multiply 2 and 9 to get 18? Yeah. Can I find a way to subtract a 2 and a 9 to get 7? Yes. And so since this is negative, the 9 is going to be negative and the 2 is going to be positive. So if I were to check my work and FOIL this out, x times x is x squared. X times -9 is -9x plus 2x. -9x plus 2x is -7x. And 2 times -9 is 18. Hooray! Hooray! My daughter is playing my phone, so if you heard a an angel didn't get its wings. Somebody needs to turn the volume down a little bit. It's all right. I love you anyway. Let's do it again. Okay. It's a quadratic. I need to come up with two numbers whose sum is -9, whose times is +8. Oh, they multiply to a positive but add up to a negative. That means they're both going to be negatives. Okay. Two numbers that multiply out to 8, 4 and 2. -4 plus -2 is -6. No. How about 1 and 8? -1 plus -8 is -9, so 1 and 8 it is. The order doesn't really matter. If I put x minus 8, x minus 1, good to go. Ooh, remember a minute ago where I said that if you have factoring, it could be one of several things. Like it could mean bring out a greatest common factor. Well, that's what we have going on here. I have a number in front of x squared, and usually you look at that and be like, oh, that's scary. I'm afraid. And maybe you should be. But in this case, don't be. Because I see a 7, I see a 45, and I see a 28. All of those are divisible by 7, which means I can factor out a 7, and that's what I'm going to do. When you factor out a number, you divide that number from all of these numbers, but leave the x's alone. Now, if I were to bring out an x, that's a different story, but that's not what I have. So if I divide 7 from 7, I have invisible 1. Drop down the x squared, because remember, leave the x's alone. That's a 2, but it looks bad. If I divide a 7 from -45, I have -9. Drop down the x. And if I divide a 7 from -28, I have -4. Now, usually I would look at this and be like, oh, a quadratic. Let's do sometimes. Let's see what two numbers add up to -9 and multiply out to -4. And then you think about it, and then you think about it, and then you think about it and realize I can't. So does that mean that this is not factorable? No, this problem is factorable, and I already factored it, and that's just my answer right there. Sometimes factor means just factor out a greatest common factor, and that's what this was. Factor, 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 factor. Fear Factor, remember that show? Joe Rogan. How's he doing? Now, this is where it gets a little unpleasant, okay? And I'm going to be honest, I'm not super good at these, so you'll kind of see what it looks like to have a genius struggle just a little bit. I have a number in front of p squared. No big deal. There was a 7 in front of my variable squared last time, but there's no number in front of p, which means you can't factor out a number. Can I factor out a variable? No. So the only way that I can factor is by if you deal with factoring stuff with a leading coefficient. It's gross. I hate it. But it's a guessing game. Let's see what I do know. what I know is this multiplies out. It's still kind of like sometimes, but not really. This multiplies out to a negative 18. So you put a plus there, you put a minus there, because it's negative 18. Now, the nice thing is, since this is a 5, one of these has to be 5p, and one of these has to be regular p. I just don't know which one's which. Now, why is this 5p and why is that regular p? How else are you going to get 5p squared if I were to FOIL this out? Now, there's a problem. These signs might change if I chose the wrong parentheses. So that's something that we have to test out. Now what I have to do is I have to come up with two numbers that multiply out to negative 18. So if I do a 3 and a 6, let's see what happens if I put the 6 here and if I put the 3 here. Okay, I know it's going to be 5p squared. I know it's going to be negative 15 p and positive 6p, which doesn't work, not even close. So I don't like the 6 and the 3. And if you're like, well, swap the 6 and the 3. Swap them. If I swap them, then that's going to be 30 over here. No good. So the 6 and the 3, probably not a good idea. Let's try 9 and 2. So if I were to put the 9 here, I know that I would end up multiplying 5 times 9, which is 45. So I'm going to put the 2 here and the 9 here, and I'm looking at this thinking, this has promise. If I were to FOIL this out, 5p times regular p is 5p squared. 5p times negative 2 is negative 10p. 9 times p is positive 9p. And 9 times negative 2 is negative 18. When you combine these, you get negative p. We did it! Now, you might be thinking, because I did mention this earlier, what if for some reason I have plus p? And you're thinking, oh, I'm so close. What do I do? Switch the signs, and then you'll get it right. But I got it right on my second attempt. Good for me. Sometimes it's not as simple. You know, there's other methods that you could do this. One of them is called MUDs. I have a video on the YouTube where I call it the Nick Parrish method. I use a rainbow, but that is very tedious. If you use that method, it's tedious. I don't like tediousness. It's a sin. Now I have a solved problem. Now, when you solve a quadratic, you are dealing with something called the zero product property. I almost misspoke. Zero product property. What's that? If I have a parentheses and a parentheses, in fact, let me do this. If I have a parentheses times a parentheses and it's equal to 0, what you do is you set one of those parentheses equal to 0, and you set the other parentheses equal to 0, and you solve the stuff on the inside. What I'm going to do here is very much the same thing. Issue number 1, I need it to equal 0. So let's subtract 2 from the right side so it can equal 0. Erasing using the small eraser takes a while. Let's subtract 2 from both sides. -2, -2, cross u out. Negative 2 doesn't combine with b squared or b, so I have b squared plus b minus 2 equals 0. Now it's a quadratic. I need two numbers whose sum is 1 and whose product is -2. Well, it's going to be b in here. One of them is going to be positive. One of them is going to be negative. 2 and 1, I can do 2 minus 1 to get invisible 1. So let's make the 2 positive and the 1 negative because it's 2 minus 1 giving us that invisible 1 that lives right there. Still equal to 0. Now remember what I wrote over here. You take each parentheses and set them equal to 0. B plus 2 equals 0, and b minus 1 equals 0. Subtract 2, b is negative 2. Interesting, the opposite of 2. Add 1, and b is 1. Interesting, the opposite of negative 1. So a little trick is if you're doing zero product property, and if what you have is a variable plus a number or a variable minus a number, your answer is going to be the opposite of the number in there. Okay, so I guess more appropriately, I can write this answer out as negative 2, 1. There you have it. That's what b is. Fun. Now it gets worse. Let me see. Let's do the same thing. I got to get rid of 65, so let's subtract 65n from both sides, not just 65 to 65n. Let me skinify the pen because I have a feeling I'm going to need space on this one. So that's 10n squared minus 65n minus 35 equals 0. I have a 5 in common in all three of them, so let's factor that out. Let's factor out a 5. If I divide 5 from 10, that's 2n squared. If I divide a 5 from negative 65, it's negative 13n. And if I divide a 5 from negative 35, that's going to be negative 7 equals 0. Let's see if I can factor that guy in there. I'm pretty sure I can. And if I can't, there's something that I could do, but I don't think I need to worry about that. Not right now. One of these has to be 2n. One of these has to be regular n. One of these has to be positive. One of these has to be negative. I'm feeling u have to be 7. U have to be 1. U have to be minus. U have to be plus. And that would give me 2n squared minus 14n plus n minus 7. I'm good. Now, as you do more of what I just did here, you'll kind of figure out the puzzle. And for me, it's all a matter of taking these numbers and thinking, look, I can only multiply 1 and 7, so I'm going to have to make sure I do 2 times 7 and 1 times 1, and that gets me the negative 13. But here I am. Here I am doing zero product property, and I'm actually going to show my work for 2 of these. I'm going to write out 5 equals 0, because technically 5 is in a parentheses. Yippee. I don't need to do that, but technically it is. I have 2n plus 1, and I am going to be lazy. Because in the last problem I just said, if I have a number and a variable in a parentheses and you're doing zero product property, your answer is just going to be the opposite, so n is 7. Okay? Now, going back over here to where it's blue, I wrote out 5 equals 0. Is 5 equals 0? No. So this guy right here, what's my solution? There is none. Ignore it. If you don't have a letter attached, you're not going to have a solution. That 5 is just kind of there to exist. Now I have here in purple 5n plus 1. So I actually have to do a little bit of math. Let's subtract 1 from both sides. That gives me 2n equals negative 1. Divide by 2, and n equals negative a half. So my 2 answers for this guy, are going to be 7 and negative 1/2, not in any particular order. It doesn't really matter the order that you have it in, but those are my 2 answers. Now, what if I did this guy? Got to that point right there, and I couldn't factor it. Does that mean there's no answer? No. There is an answer. It's just not factorable, so the answer is not going to be pretty. And that's when we have the quadratic formula. Now, the quadratic formula solves for any quadratic. What's that? A quadratic. In order to do the quadratic formula, you need it equal to 0, which it is. You're going to label the number in front of v squared a, the number in front of v b, and the number in front of nothing, that's just standalone c. Okay. Now, I have a song for the quadratic formula. It's a song. I wrote it. And if you steal it, I'm going to sue the heck out of you. It goes a little something like this. X equals negative b plus or minus square root b squared minus 4ac ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, sir, we get it. Sing it again. No, I won't. By the way, my phone rang. If you're watching this 20 years from now, this is called an Apple Watch. I'm sure if you're watching this in like 2040 something, we've reached the apocalypse. Maybe, maybe not. All right. Get that out of here. X equals negative b. So b is negative 5, c is 3, and a is 2. So x equals negative 5. I'll clean that up in a little bit. Plus or minus the square root of b squared, which is negative 5, in parentheses squared, b squared minus 4 times a, which is 2, times c, which is 3. Extend that a little bit. All over 2a, 2 times 2. Now, when you're doing this, the first thing you're going to want to do is everything inside the parentheses first, inside the square root first, which is a set of parentheses. I didn't misspeak. Negative 5 is 5, though. I can just take care of that right now. So plus or minus the square root. Negative 5 squared is 25.
Daddy, can you put mommy down here? I'm sorry to update you. Little mommy.
Mermaid?
Yeah. I'm sorry for interrupting you. I'm sweaty.
You're sweaty?
Yeah. Because I'm sweating and thank you.
Love you.
I love you too.
All right. Negative 5 squared was 25. Minus 4 times 2 is 8 times 3 is 24. Oh, God is good. God is good. You'll see why in a little bit. Over 4. Okay. Let's keep going inside that square root. Okay. That's going to be 5 plus or minus the square root of 1 all over 4. The square root of 1 is 1. So 5 plus or minus 1 over 4. Now what do I do? Well, I can clean this up. I can split this up into two problems. Okay? 5 plus 1 over 4 and 5 minus 1 over 4, because that's what plus or minus means. 5 plus 1 over 4 is 6 over 4, which is 3 over 2. Capiche? 5 minus 1 is 4 over 4, and 4 over 4 is 1. So x equals 3 over 2, and x equals 1, and that is my solution. Which means this problem up here is factorable. I could have factored it if I wanted to. I just didn't, because I wanted to get some quadratic formula practice in. Okay? Do I have another one? I don't. Now, there are times in Algebra 2 that you did quadratic formula and you probably ended up with imaginary numbers. That is possible. We're not going to see that a ton in pre-calculus. But again, the whole goal of this is making sure we know how to factor and know how to use the quadratic formula, because we will deal with what's called trig functions. And there are times where we have to do the quadratic formula every now and then. And so as an AP Precalc student, you are expected to know how to factor and how to use the quadratic formula. Also, completing the squares is going to be seen a lot in something called conic sections, which is graph that ellipse or graph that hyperbola or something like that. Graph the circle. You'll see stuff like that in pre-calculus too. You might have seen it in geometry depending on how far you got in geometry. All right, solving by completing the square means that you have to move certain things over, take half of something square, add it to both sides, perfect squares, blah, 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 blah. This is how you solve by completing the square. First things first, you need your variable squared and your variable on one side, and you need your constant on the other. I have my variable squared on the left. Ooh, my variable's on the right, but my constant's on the right. So the only thing that I have to do right now is subtract 8a from both sides. So I have my variables on the left and my constant on the right. So that gives me 2a squared minus 8a equals negative 6. Step number 2 is we have to get rid of the number in front of a squared. So we divide everything by that number, divide everything by 2. You go away and become a squared. Negative 8 over 2 is negative 4a. That's going to equal negative 6 over 2, which is negative 3. Now, I'm going to purposely leave myself some space, and you will see why. Over here, too, negative 3. Now, to complete the square, what you do is you take half of the number in front of a, so negative 2. You square that, so positive 4, and you add that to both sides. Okay? And so that leaves me with a squared minus 4a plus 4 equals 1. Every single time that you do this, this will happen. You will get a perfect square on the left. So I can factor this using sometimes, but when I do, it will always be a perfect square. So two numbers that add up to negative 4 and multiply out to positive 4 are negative 2 and negative 2. So a minus 2 squared equals 1. Again, if I don't have a perfect square, I did it wrong. How do you solve for a square? Square root both sides. Do not forget that when you square root both sides, the side that is the number is going to be positive or negative. That crosses out, and we have a minus 2 equals positive or negative square root of 1, which is 1. I add 2, and now a equals positive or negative 1 plus 2. You split this up into two problems, okay? Where you have positive 1 plus 2, 3, and negative 1 plus 2, 1, and those are my two answers. Which means this problem is very factorable, but we did completing the square because I wanted you to see the process. You got to trust it. Trust the process. Sixers. Did I skip one? Find the zeros is just a fancy way of saying make f of x 0 and solve. So I'm going to do that. I'm going to make f of x 0, and I'm going to write out x squared cubed minus 2x squared plus x. I have to factor this out. Oh, look, there's an x in common and everything. Let's bring out an x. So when you divide out a variable, which we haven't done yet in this video, if you divide out one variable, you subtract each degree by 1. So x cubed is now x squared. Nothing happens with negative 2. X squared is now just x, and if I divide an x from an x, I'm left with an invisible 1, or I'm going to write out the 1. Can I factor that guy out? Yeah, I can. 0 is going to equal x. Two numbers that add up to negative 2 and multiply out to 1 are going to be x minus 1 squared. So using the zero product property, I have x equals 0 because you set each, remember you can pretend that that's in a parentheses, so x equals 0, and x minus 1 squared equals 0. Square root both sides, positive or negative, square root both sides, cross you out, x minus 1 equals the positive or negative square root of 0 is positive or negative 0 or just 0. Add 1 to both sides, and x equals 1. So my two answers are 0 and 1. Now, what I should have done and what I could have done is I noticed that x minus 1 is being squared. I didn't need to go through all of this. I could have just said, isn't that just going to be the x minus 1? The opposite of negative 1 is positive 1, and that's my answer? Yes. Some teachers might have you say that the multiplicity is 2. That just means you use 1 twice technically. But, we're not going to lose any sleep over that. Some people also say double root. But there you have it. All right, this is my last one of section 2. We have to graph this. Now, I'm not getting a calculator. I probably should have used the word sketch, which means I know very well that my picture is not going to be 100% perfect. And that's okay. The only perfect person is Jesus and me. And my little 5-year-old that you saw earlier. Isn't that right? She shook her head yes. So when I graph this, I noticed right away that this is a cubic. The leading coefficient is positive, and positive cubics look like this. Okay, positive cubics look like that. What I'm going to do is I'm going to keep that in mind and keep that off to the side. Nothing to factor out. Can't do factor by grouping. No zeros in common that I can tell right away. I'm just going to have to do this off the old dome. So what I'm going to do is I'm going to make an x, y table and include a ton of numbers. It's going to be tedious. That's all right. Let's do -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. And if I have to add more, then I'll add more. And we're going to do a lot of this using mental math. Okay. And in fact, if I realize right away that some of these won't follow on the graph, I won't go any further. And what I mean by that is when I plug in -5 to the third power is -125. So if the number is just going to be like 80, and I realize that immediately, I can't graph 80. I'm just going to quit right there. So for example, if I plug in -5, I'm going to get -125 because -5 times -5 times -5 is -125 plus 25 because -5 times -5 is 25. And then minus -5, no. Number's going to be huge. I'm not doing it. If I plug in -4, that's going to give me -64 plus 16. Minus -4 is +4. Minus 2, again, too big. No. If I plug in -3, I get -27 plus 9. Minus -3 is going to be +3. And then minus 2. So that's going to be -17, I think. Either way, too big. Now it's probably going to be manageable because I went from huge numbers to -17. I'm getting to the point where I should be able to graph it soon. If I plug in -2, okay, I'm on -2 now. If I plug in -2, I'm going to have -8 because -2 times -2 times -2 is -8. -2 times itself is going to be +4. Minus -2 is going to be +2 minus 2. So this ended up being -4. So that is certainly manageable. Okay, certainly manageable. By the way, this is going to be a really big, what did I say this was? -17? But I already knew that it's going to look like that. So that's I just kind of waste my time there. If I plug in -1, I'm going to have -1 times itself is -1, plus 1, minus -1, which is plus 1, minus 2. So 2 minus 2 is 0, minus 1 is -1. If I plug in 0, you all go away and I get -2. If I plug in 1, I get 1 plus 1 minus 1 minus 2 is -1 again. If I plug in 2, I get 8 plus 4 minus 2 minus 2, which is 8. If I plug in 3, I get 27 plus 9 minus 3 minus 2. The numbers get huge. So these are going to be no good, no good, no good. Numbers are just going to be too big. So these are really the only points that I have going for me, all 6 of them. Okay, so I have -2, -4, which is going to be -2, -4 right here. I have -1, -1, which is right here. I have 0, -2 right there. I have 1, -1 right there. And I have 2, 8 way up here. Now, I know this isn't perfect, right? And my job here is not for perfection, but is to get a somewhat accurate picture. And this is a somewhat accurate picture. In pre-calculus and in regular calculus, you will be able to find out the exact points where these things peak out and bottom out, but we're not going to worry about that here. You will also learn how to do that in pre-calculus. So if you're like, how do I know that's not the maximum? How do I know that that's not the minimum? It may not be. But I'm not going to worry about that right now. I'm just getting a general idea of what this graph looks like, and I'm all right with it. So, section 2 was mainly about quadratics. We had a trinomial here, or a cubic, not a trinomial. We had a cubic here. There's going to be 3 more sections that we're going to look at before we deal with the end of getting ready for AP Precalculus. So, keep on watching. Make sure you rewatch this again if you're not sure. And thank you. And don't forget to hit that little subscribe button. Make me some money. Please. Bye.